Okay, welcome back. Working in now 3.4. What we're going to do is tack on quantifiers to our arguments. So 3.4 arguments with quantifiers. So your universal or your existential. In particular, we just look at the universals. But the first thing we need is universal instantiation. And basically, if you know something is true for all items in some set, then you could say there is an item in there such that whatever quality that is true for all of them is true for that particular item. Okay, so if it's true for everything, it's true for a particular. Okay, so a lot of times in proofs you'll want to kind of pull this particular object out of the etherness and work with that. So it's kind of the Rumpelstiltskin effect. You give it a name and you could work with it and do something about it. So it seems a little silly in the exercises. For instance, number 1, they want you to use universal instantiation to basically make your conclusion, I believe. So they give you for all real numbers, A and B, A plus B squared is equal to A squared plus 2AB plus B squared. So one, a next statement could be A equals 1 and B equals 2 are real numbers. So the conclusion you can draw from the universal instantiation is that 1 plus 2 squared is equal to 1 squared plus 2 times 1 plus 1 times 2 plus 2 squared. You can let A and B be anything. You can let it be x and y, and then you just be putting x plus y squared equals x squared plus 2 times x times y plus y squared. It just seems silly, but it's important. It's the Rumpelstiltskin idea. You bring it into existence, and you can play around with it and work with it and see what happens. Okay. Okay. So that will be important later on. Okay, so number 8, we have an argument, and we're going to work with modus ponens and modus tollens and the converse error and the inverse error and transitive arguments, the transitive rule for arguments. So anyways, this will be embedded in all of that. But anyways, the argument is all freshmen must take writing. Okay. Caroline is a freshman. Okay. Therefore, well, the conclusion, what's the conclusion that follows? If this is a particular instance and it's true for all freshmen, it must be true that Caroline needs to take writing. Okay. Must take writing. Okay, and that's going to be a valid argument by universal instantiation. I'll just write UI instead of having to write all that out. Okay. Okay. So the other types of arguments then, as promised, here's universal modus ponens. And it's basically the same argument from before, if you recall how that worked. It was if P, then Q, and then somebody says P, your conclusion is Q. The only difference now is that these are kind of variable statements with a universal quantifier attached. So now you're going to see something like for all x, P of x implies Q of x, and then you do an instantiation. So for in particular, P of A is true, therefore Q of A must follow. Okay, so that's universal modus ponens. Then modus tollens, universal. Recall how that worked. So recall if P, then Q, not Q, imply the last conclusion then would be not P. Okay. So now what we'll do is just say, all right, universally it's true. Universally, P of x implies Q of x. So in particular then, if somebody gives you not Q of some particular value A, you can conclude not P of A. Okay, and then the converse error and the inverse error, same as before, converse error. Okay. So recall from before how that worked. If P, then Q. Q is given, therefore P. So that's not always going to be a valid argument. But now the way it works, you just tack on a universal, and you're dealing with predicates for all x. P of x implies Q of x. Somebody's giving you Q of x, or sorry, Q of A, and then you're concluding P of A. That might not necessarily work, right? So then lastly, the inverse error. So recall that argument type from before. If P, then Q. Then they give you not P, and you conclude not Q. That's not going to work, right? So now the only difference is you have that universal and that with an instantiation. So for all x, P of x implies Q of x. We're supposing now on top of this not P of x, or rather P of A, and then you're concluding not Q of A. And of course that will be not always valid. So the problems in the book and in WebAssign are going to give you an argument. You have to determine if it's valid or invalid, and then tell why. Right? So let's look at some of those. And rearranging my papers so I don't. Sorry. So let's look at number 2. In the book, and it says if an integer equals 2 times k, and k is an integer, then n is even. So the second statement, 0 is equal to 2 times 0, and 0 is an integer. And the conclusion for 0 is even. Okay, so is it valid, invalid, and then the form of the argument. So it looks like what do we have? It's a universal with if, so it's P then Q. The second statement, they're given an integer, and the integer they give a name n. Sorry. In this case, they instantiated 0. Okay. So in particular, here we have an integer 0 equals 2 times 0, and 0 is in the integers. So that's the first part of the conditional, that's P. And then they conclude this particular integer is even, which is the last part. That's the q part. Then n is even. Right? So then they concluded q. So what is this? This is universal modus ponens. I'll just write universal modus ponens. Okay. Let's look at another 5. All irrationals are real. In other words, if you're an irrational number, then you are real. So that's a if p then q. 1 over 0, we instantiate for a number, is not real. Therefore, 1 over 0 is not irrational. Okay, so you may have to kind of rewrite these statements into a conditional form. So this is for all numbers x. If irrational, I'll just write I of x, then R of x. Right? They're saying that 1 over 0 is not real, so not R of 1 over 0. And then they conclude not I of 1 over 0. Okay, so the argument form is modus tollens this time, so it must be valid. So you should note if it's valid or invalid. The previous exercise is valid. This one also will be valid, and it's because of universal modus tollens. 2 more. And we'll move on to something else. Let's look at number 11. For all cheaters, x sits in the back row. Monty sits in the back row. Therefore, Monty is a cheater. So you hope your teacher doesn't think this way if you sit in the back row. So what's the form here? So it's for all x. If x is a cheater, so we'll say C of x, then x sits in the back row, so we'll say B of x. They're saying that Monty in particular sits in the back row, and then they're concluding that Monty is a cheater. Oops, so C of m. Okay, this is clearly invalid. It's the Converse error. Okay. Okay. One more. So they'll try to confuse you with more and more informal type arguments. But it's good to be able to translate back and forth. In particular, no good car is cheap. A Rimbaud, whatever the heck that is a good car. Therefore, a Rimbaud is not cheap. Okay, so the form, you may have forgotten no good car is cheap. This means for all good cars, x is not cheap. And then to rewrite that as a universal conditional, for all objects x, if x is a good car, so we'll say g of x, then x is not cheap. So we'll say I don't know, not cheap of x. Okay. So you may have to translate a little bit in order to pull these off. The second statement then, in particular, the Rambau is a good car. So G of R is given. And then they're concluding Rambau is not cheap. Okay. Clearly this is valid, and it's a case of universal modus ponens. So valid universal modus ponens. Okay. The next part, they'll have these kind of Venn diagram type things. Sort of give you an idea of how you'd go about proving in a more in kind of a different way. I don't think that this would be a formal proof in any way, but it gives you an idea of how these things could be proved. So proving validity using diagrams. In the software and my WebAssign and WebAssign, they're going to give you multiple choices. The only weird thing about it is sometimes there's more than one answer, and you have to make sure you hit all of the ones that are true. Okay, that's when I went through the exercises that kind of screwed me up. I was like, oh, this one's true. I don't know why it's not marking me wrong. You have to click all the ones that work, or all the ones that don't work, or whatever they're. Read the directions, see what they want. Just be careful on these. The way you're going to do it is draw the premises as sets. Okay, so first, I guess if I had to write a program, I would draw the premises as circles, or which represent sets of objects. Okay, and the circles can be intersecting, disjoint. In other words, they don't hit each other, or they could be one inside the other. Okay, so they could look like this. That's intersecting. Disjoint means that they don't touch each other. Their intersection is empty. Or they could be nested. So one completely contained inside of another. Okay. And again, there's more than one way to draw it sometimes. And then ask yourself, does the conclusion follow? Okay, so let's at least try one of these. This is example 3.4.7 in the book. And the argument, no polynomial has a horizontal asymptote. No polynomial function has a horizontal asymptote. Let's make sure we get all the little details. Okay, so that's our first statement. The second statement, this function has a horizontal asymptote. And then the conclusion, therefore, this function is not a polynomial. Okay, so first thing, you may want to just convert it into a more formal notation with symbols, get rid of the no, blah, 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 get rid of any unlesses, they throw those in too. So maybe we can write this as for all polynomial functions x, x does not have a horizontal asymptote. So for all objects x, if x is a polynomial, then it does not have a horizontal asymptote. So no horizontal asymptote. Or maybe we could just write not horizontal asymptote. The second statement says this function, this particular function, has a horizontal asymptote. So h of a, basically. And then the conclusion, therefore, this function is not a polynomial. So not p of a. So what form is it? You can still kind of play that game and kind of see whether it's true or false in that regards. In particular, this guy right here, h of a is equivalent to, by the double negative law, negative h of a. Okay, so what form is this? This is universal modus tollens, and it's a valid argument, right? So they gave you not this, and you concluded not p. So let's put it into our diagram form now. Okay, so there's going to be this set of things that have horizontal asymptotes, right? We call that set H. So if something is in the set of polynomials, it can't be in the set of things that have horizontal asymptotes. So I'd have to draw those as disjoint sets. So there's my set of polynomials, and none of these are in the set of horizontal asymptote guys. Right? Now they're taking a particular instance. This function has a horizontal asymptote. Right? So functions that have polynomials are automatically going to be functions, right? So that you could say that the set of functions, if you want to make it more detailed now, is going to include all of these polynomials, right? So the set of functions includes all of the polynomials. And it also includes some of these guys that have horizontal asymptotes. Okay? We're saying that this function has a horizontal asymptote, so it has to be over here. And in other words, this function is not in the set of all polynomials. Okay? So you could kind of clearly see that this is a valid argument just by looking at the diagram. Okay? Okay, and then you can start thinking, hey, are there other ways to have drawn this such that you also get a contradiction? Are there other ways to draw this so it's still true? Well, you could say here's the set of all things that have horizontal asymptotes. Maybe it's not clear that, or maybe it is clear that all things with horizontal asymptotes are functions. Maybe that was the case. We don't know. Okay. All we know is that polynomials, if you're a polynomial, you're not in the set of horizontal asymptote things. So this guy has to exist out there, no matter how you draw f. Okay. So whether or not all the polynomials are actually functions, you would need to know a lot about math, or maybe a little bit about math, to know that is true. So somebody who knew nothing about math would maybe draw it like this. The set of functions intersects with the set of polynomials, and then the set of functions intersects with the set of things that have horizontal asymptotes. And then again, if something has a horizontal asymptote, it's still not going to be in this set of polynomials. Anyways, in the WebAssign, they're going to give you, it's multiple choice again, so they're not going to expect you to draw these diagrams. They'll give you the diagrams, you just have to figure out which ones work. Okay. Okay. The last sort of argument here is the universal transitivity argument. Okay, and basically, if you have some universal statements, for example, P of x is true, P of x implies Q of x for all x, and then you have for all x, Q of x implies R of x, then you can conclude for all x, P of x implies R of x. Okay. So the last set of problems in WebAssign will kind of give you this informal argument, and then you want to translate it into a bunch of implications, and then chain the implications together in a way that they sort of all connect to give you the final if P, then R. Okay. They're challenging to say the least, but fortunately in WebAssign they give you kind of a drop-down set of statements that are translated. You're going to have to be able to do contrapositives. You're going to have to be able to work with very informal sentences in the book and translate them. Okay, so let's maybe look at one. This is 31. And you give a list of statements, and I'm going to translate as I go every statement into a more formal statement. So the first statement, I trust every animal that belongs to me. So a better way to say that is to say, for all x in the set of animals, if x belongs to me, then I trust it. Okay. So like I said, in WebAssign, they'll kind of give you this statement, but it's all jumbled, and you have to put them in order. Okay. Okay. Secondly, then, the second statement in the book, problem 31, dogs gnaw bones. Okay, so I want to convert that for all x in the set of animals. If x is a dog, then x gnaws a bone. Third statement, I admit no animals into my study unless they will beg when told me when I tell them to beg. Right? So the unless, you sort of have to negate and flip. So how did unless work? R unless S is equivalent to saying if not S, then R. Okay, so you got to remember all those little technical rules. So in particular, we'll say for this statement, the third statement, I admit no animals into my study unless they will beg when told to do so. As a conditional for all x in the set of animals, if x does not beg, then x is not admitted to the study. Okay. Statement 4, all the animals in the yard are mine. So for all x, if x is in the yard, then x belongs to me. Statement 5, I admit every animal that I trust into my study. For all x, if I trust x, then I let x in my study. And then finally, the last statement, the only animals that are really willing to beg when told to do so are dogs. So for all animals x, if x is willing to beg, then X is a dog. Okay, and so for our conclusion, what we want to do is kind of connect all of these implications together using that transitive property, right? So you may have to use contrapositives to make them hook up. And, you know, so you kind of look in here, and if it belongs to me, I trust it. So is there one that starts with I trust it? So you can go from and kind of look at the order here. So I write it the order here. So if I start with 1, and you wouldn't probably start with 1 because they're going to be scrambled. If I start with 1, I can go to number 5, right? Because that begins with trust. And then I let X into my study. So you look for one that begins with letting X into my study. And there sort of isn't one, but there's this guy. Okay, if X does not beg, then X is not admitted. You can write it as a contrapositive. If X is admitted, then X begs. Okay, so we could go from 5 to the contrapositive of 3. And then we need something that begins with begging. Okay, so 6, right? If X is willing to beg, then X is a dog. So we need something that begins with a dog. So 2. If X is a dog, then X gnaws bones. Okay, and then is there something that begins with gnaws bones? If not, that's your conclusion. Okay, that'll be the Q part of your conclusion. So X gnaws bones. We just need the beginning statement. Did we get all of them? So we got 1, 5, contrapositive 3, 6, 2, and then 4. Does 4 hook up to 1? Yeah, so 4 hooks up to 1 because the end of 1, X belongs to me, and the beginning of 1, so the end of 4, X belongs to me, the beginning of 1 is X belongs to me, so 4 comes first. So if X belongs to me, so if X is in the yard, then X gnaws bones, okay? So that would be my conclusion. If X is in the yard, then X gnaws bones. Okay, those can be kind of a little annoying, but it just takes a little bit of time to get through them. Okay, so that should do it for all the material up to now. Will be on the first test. I'll probably just put the first test in WebAssign and let you have at it. It'll be timed. You only get 1 attempt. Obviously, I can't keep you from using note cards or anything, but I would expect that you're not, going online and using online sources or anything like that. But it'll be timed, so odds are you're not going to have time if you don't know anything to go through and read and figure it out. And additionally, I will be putting this material on the midterm. So you're going to, on the midterm, you're going to use ProctorU. And what that means is they're going to literally be watching you when you take the test. So you'll need a webcam, and you'll reserve a day to take the test. I'll give you a week to take the test. You have to reserve it ahead of time because they are swamped because of the pandemic. Everybody and anybody is trying to use ProctorU. Okay, so you'll have to make sure you reserve it as soon as you can. I haven't set it up yet, so you can't do it today. You'll have to wait. I'll tell you after I've set it up in ProctorU, so you can start making reservations for the midterm, but that's a little while off. Okay, so anyways, this ends the material that's going to be on the first test. I'll probably put this first test in WebAssign. It'll be timed, And okay, so that's about it. See you next time.